Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is a hot or cool topic. I don't know, whichever way you see it. Used in hot weather to cool you off, right? AC systems diagnosis. I know it's a cheesy dad joke, but it is that time of year. As I'm filming this now, it was even more last time I filmed this. As a matter of fact, we were going through a bit of a heat wave, both in the U.S. and over in the U.K. Last time I was having this conversation with you, so interesting timing, as it were. But we're going to talk through kind of the two different portions of the gear, right? So we're going to talk through uh, all of the different plumbing and the blowers and the compressors and all the little components that we need to worry about when it comes to our AC systems, right? It's knowing how they operate makes it easier for us to get them to work properly. So first off, we'll start on the exterior of the vehicle, or mainly on the exterior. So it all starts with a compressor, right? That's what moves the refrigerant around. And you got the clutch, of course. You got the oil in there, which can be a different oil, and refrigerant, which is multiple different refrigerants as well. We'll talk about that. The evaporator, which I guess technically is inside, but that's the only piece that is. And of course, the condenser on the other side, that's usually by the radiator. And the receiver dryer, which also dries out the refrigerant. There we go. Expansion valve, which helps regulate the pressure, and then pressure switches for feedback into the system, so it knows where the pressures are at. Sometimes it's just a high pressure switch. Sometimes it's high, low, and mid pressure switches. It just depends on the OEM and what they do. So the refrigerant carries the hot air from the passenger compartment and carries it back to the compressor, where it is then compressed down into a liquid, right? So start with the compressor, as we said. So the majority are belt driven. Hybrid and EV are electric. There are some non-hybrid or EV vehicles that also use electric refrigerant pumps, compressors. Belt-driven uses an electromagnetic clutch. The clutch can be tested with a scanner or component testing. So usually there's going to be a bidirectional control that you can do to make sure that it goes on and off. Otherwise, you could use component testing and things of that nature to make sure, the continuity and so on. If it's going to fail, usually, unless it's leaking, I find the clutch fails more often than anything else. They can be what we call fixed displacement or variable displacement. So variable displacement may actually not use a clutch either, because you can just set it to wide open with that, where it's not actually pumping anything. So here's one version of a compressor. All right, so we have the pistons, and it's got a cylinder head. It's kind of like a small engine, right? So we got pistons, and we have this little wobble plate here. So as it spins, this plate wobbles, and then it presses the pistons down. Oops, too fast. Presses the pistons down, and then they come back up, depending on where it is in the wobble. And they have this connecting rod, of course, just like I said, very similar to an engine. So an engine is basically just an air pump. So charging port, suction and discharge connections. So everything kind of goes in here. There's little valves inside and such that could fail, I suppose. But here's kind of how it works. This is a swash plate compressor. So this is one where the plate kind of moves like that, right? It's got running on like a U joint in the middle, and it pushes the pistons up and down. Right? So as they kind of rotates, And we got some bearing type situation going on there, and it just kind of pushes it up and down, as you can see. All right. And then a wobble plate compressor, instead of having like that universal joint in there, it's just the plate itself is cut on an angle. So as it moves around, it just pushes them in that way, right? So it pushes them around and causes the pressure to increase, of course. Also, it's not usually just two pistons. Usually there's multiple pistons around with this cutaway, right? So usually multiple pistons in there. And then we have a variable displacement compressor, which will have the plate that goes around, so it's a wobble plate, but it can vary the angle as to what that wobble plate can be. So here we have it on a reduced or minimum angle, so we can see it's quite low, so the piston doesn't move as far. And then at a maximum angle, we can see how the piston can really move all the way in there, right? So in this case, it doesn't push as far, so it's not increasing the pressure as much, whereas over here, it's doing the full stroke of travel and increasing the pressure more. And it's controlled by this control valve in here, which moves that, moves this piston here back and forth, or like it's a rod, I guess I call it. Then we have electric compressors. Electric compressors are generally going to be your scroll type compressor. So it's got a DC motor in here, or at least this one is anyways. Got a DC motor, refrigerant comes in, the scroll ends up compressing it through the scroll, and then it goes out as high pressure on the other end. And has no belt drive at all. It's just like I said, it's an electric DC motor with that. They do require a special oil, and we'll talk more about that in a minute. Also found an interesting troubleshooter tip somewhat recently. It's on a Toyota Tacoma, 2019 Tacoma. I think it's a pretty good year range that this covers. But for a B1422 code, so that is going to be your body control code or body system code for B. It's compressor lock sensor circuit. So the PCM relays the engine speed signal to the AC amplifier assembly via CAN. The AC amplifier assembly monitors the difference in the AC compressor speed and the engine speed. If the PCM is detected too large of a difference in the AC compressor speed versus the engine speed, this code will appear. To begin diagnostics of the code, start by turning the AC on and monitoring the compressor with the engine at idle. If the compressor pulley operation appears loose or erratic, suspect a failing compressor assembly. If all appear okay, perform an inspection on the lock sensor wiring harness and connector. No obvious signs of damage or fault are present with the ignition off. Disconnect the AC lock sensor connector and inspect the connector terminals for corrosion or burning. No faults are present. Use a multimeter to verify the presence of voltage and ground. If both are present, measure the resistance of the lock sensor between speed sensor negative and positive. Should be 160 to 320 ohms. If it's okay, using a set of fused jumper wires, apply battery voltage and ground and a magnet voltage supply terminal and ground terminal on the AC lock sensor. If the clutch does not engage, suspect a failed magnet clutch assembly. In some cases, a loose serpentine belt can also cause this code to appear. And additional notes, Toyota recommends replacing the AC compressor assembly when the lock sensor has failed. The lock sensor can be replaced without replacing the entire compressor assembly. Even though Toyota recommends it, you can replace it separate. So here's kind of the deal there, right? We can see it's got like a little sensor there, a couple bolts, etc. So it can be had by itself. So that's a little time saver, money saver tip, I guess, if it's just that particular sensor goes. I was not aware that it was could be a problem. So when I saw that tip, I figured, hey, perfect timing for this class. So speaking of guided component tests, in our tools that have the guided component test, the scope multimeter thing, there's a fair amount of HVAC things you can test. So AC clutch relay, AC compressor clutch. There's that lock sensor there, pressure sensor, ambient air temperature sensor. We're going to talk more about in a little bit. Blower motors, relays, resistors, heater relay. So if we go into the lock sensor and we go into component information, consists of a pickup coil and a tooth rotor. The sensor outputs an alternating current waveform signal and enables the AC amplifier to verify the clutch is locked and compressor is operating. Also acts to warn of drive belt failure. If compressor is not turning, the system will shut down. So it is basically just an analog, like a crank sensor. It's going to give you a AC waveform with that. So mounted in the middle. And then we have a resistance test. So red, the lock sensor signal, blue to chassis ground. And the resistance, once again, should be 160 to 320 ohms at 68 degrees Fahrenheit. And then the signature tests. If we're going to have it turning, we're going to be back probing it as it's connected. And then we'll turn the compressor clutch on. And then we will see an AC wave form going up and down on either side of 0, right? All right, now we talked about the compressor. Let's talk about the different refrigerant types that we've seen around here in the industry. So it's R12 was one of the early ones, right? That's pre-1994, and then they phased that out and came out with R134A, which then they decided to phase out as well. That ended up being phased out entirely in 2021. 1234YF is our current state of refrigerants right now, and that started getting phased in 2012. So there's a lot of overlap on the 134 and the 1234. So make sure you are putting the right refrigerant in the vehicle. And then for a little experiment, I guess, somewhere in there in the last, I don't know, it's probably 5-10 years ago now, they tried using a different refrigerant, R744, in some Mercedes ENS class and the European market Audi A8. And I think they figured out that it didn't really do much for them, so they went back to 1234. So that's about where we're at right now. I always have people asking me and hearing rumors that, hey, they're working on a new refrigerant or something. I haven't heard anything. I've talked to the guys at Max every once in a while. They're in Pennsylvania, I think it is. That's the mobile air conditioning people that kind of come up with all this stuff. So I haven't really heard anything. So not really sure. But anyways, always check your little sticker under the hood. And when in doubt, look it up in service information then. All right, so as I said, there are different levels of refrigerant. There's different types of oil. So we have R134A belt-driven compressors. That's still, I would imagine, the vast majority of the market because it was around for so long. And there was that overlap with 1234 as that slowly phased in. So you just got to be aware of the type and weight, and also the oil. This uses PAG oil, it says. Then we have hybrid compressors, so electrically driven compressors. Toyota switched the Prius to an electric compressor in 2010, even though it has an internal combustion engine. And that one uses a different type of oil. You see there, it's 134, but it's a different type of oil, the ND oil. And then 1234YF belt-driven compressors are first introduced in 2013 Cadillac XTS in the U.S. market, grown to nearly half a 2017 models, and at this point, they all have them. At this point, 134A equipment cannot service 1234YF because the fittings are different, the refrigerant mixing and safety requirements. We can't have that either. And you also see that it takes another type of oil over here. And then if we go to 1234YF electrically driven compressors, that still uses the same oil, but it is the refrigerant cannot cross-contaminate and the oil cannot cross-contaminate, right? So we don't want it. That's why, in order to not have them cross-contaminate, there are a full line of different AC machines that will do different things. So we got hybrid alone, so you can kind of keep that oil kind of segregated, I guess. Dual 134 and 1234YF machine, so it does both in the machine, and then it has dual pumps and dual tanks and all that. 134 only, 1234YF only, and then very recently, like this spring, came out with a new line of the Polartec machines as well. So these are good for 1234YF electronically driven compressor and belt-driven compressor. So it's a 1234YF machine. Same with the dual, and then same with the by itself. And then you can kind of see how everything else shakes out as to what their use case would be. So expanded the line with these new units up there. Pretty cool. Got a little touch screen. Gauges go up and down. Kind of wanted to show you one, but we didn't have one. We haven't gotten one in the shop yet. So, all right, and then make sure that you are checking. This is 1 year difference. So we got a 16 Ford Focus and a 17 Ford Focus. You could think looking at them they're the same, but it takes different caliber of PAG oil, and one takes 134 and one takes 1234YF, and there is a slightly different like 1.37 instead of 1.3 pounds. So you got to make sure it's accurate. And most vehicles now are going to be critical charge vehicles. So if you're off by fractions of a pound, it's not going to work properly. So just make sure that you have a nice accurate scale in your refrigerant machine, whatever one that happens to be. Now we'll get to the evaporator. So it's in the passenger compartment, right? Warm interior air will blow over the fins. It works like a radiator, but instead of cooling, it uses refrigerant. As heat is removed, liquid is going to turn to vapor, and then that causes that to expand. Usually it's in the heater box near the heater core. If you're really lucky, you might be able to change it without having to pull the heater core. I know there's some vehicles I've worked on, a couple Subarus, where you were able to just kind of get the lines off, and you're able to sneak, pull it out of the box, which was nice. It was pretty few and far between, but it can be done on some vehicles, which is kind of nice. Better than the heater core. Heater core usually you can't at all, but at least the evaporator's right there. Same type of deal. Then the condenser's on the other end, right? So it takes that expanded, warmed up vapor and condenses it back down into a liquid by removing the heat from the refrigerant. So it's ambient air and the fan cools the refrigerant. It condenses into liquid. Usually it's going to have a secondary fan that's on when the compressor's on as well. So make sure the fan works too. Otherwise, that might cause issues. Then we have the receiver dryer. It's going to filter the refrigerant. There's a desiccant inside that removes water vapors in there. Should be changed anytime the system is open to the atmosphere. So anytime you're cracking it open to the atmosphere, liquid can get inside, and then fills up the desiccant, and that stops working. All right, so that is always recommended to be changed at the same time as any component in the system. And the expansion valve or expansion block, depending on manufacturer, steps down pressure before it enters the evaporator. So you got high pressure liquid coming in, and then it's going to step down the pressure through this little needle valve, this little metering orifice, they call it. It's used on most 134A and 1234YF vehicles. The outlet pressure helps regulate the inlet pressure. So if we have the outlet pressure here, it's going to kind of push up on the diaphragm there, which is going to help with this ball and the orifice down here, allowing lower pressure to go to the evaporator. Can be a common failure point. I replaced tons and tons of these in my career because it's usually also a central point where the lines go in to the firewall, or roughly near the firewall. So there's O-rings in there; they can dry out or whatever. So oftentimes you will find a leak here, if not somewhere else. But oftentimes is a prone to failure point. And then we have pressure switchers. They just power on and off depending on pressure. It's just going to send a simple signal on or off. Can be separate, high, low, or medium. Can also be a combination switch that does high and low, or high, low, medium, what have you. It's basically just the pressure comes in, pushes down on the diaphragm, which then when it gets to a certain pressure to overcome the diaphragm, pushes that down, closes the contacts, and then sends the power out to the clutch. The simplest ones are just basically just to turn the clutch on and off. Some more advanced, sophisticated ones will send data back to the computer, and it controls it that way. So it just kind of depends on the manufacturer. Then as far as controls and electronics on the inside of the vehicle, so that was like the engine compartment mainly. So now on the inside, we turn to the inside. Sensors, inside and outside temperature sensors. Sun load sensor or sensors, could be multiples. Blower motors, the blower motor controller. Actuators, mode doors, blend doors, recirc, of course the actual doors themselves, and so on and so forth. But there's a lot of different things that could be in here. So we see temperature sensors inside the vent as well. On some really fancy vehicles, they'll have that. So the computer knows what the temperature is coming through the vents. So if we start with the sun load sensor, it's a photodiode. It's usually on the dash somewhere. I know on my car I have two because it's dual zone climate control. It is a photodiode which converts solar radiation to voltage, and the control module uses this as an input to understand how hot the sun is beating down on you that day. As it's trying to cool the compartment, it's going to kind of depend on, it's going to need to know how much work it needs to put out, or how much how long it needs the pulse width on the clutch and such. Ambient air temp sensor converts ambient air temp to a voltage. So it's just going to be a thermistor that kind of senses the outside air, right? So this is usually used as an input, usually in the front bumper and shielded. So it's not just going to be sitting out there in the grill exposed to cold air or hot air blowing over at wind chill factor type of thing. It's usually going to be behind something in the bumper and fascia or whatever. That way it's not affected by the wind moving over it. Can kind of get a true ambient temperature of what's going on outside. Because once again, the computer needs to know this to know how much it needs to cool the vehicle. Cabin air temp sensor as well. This is going to be used generally speaking on anything with auto AC, where you set it. Okay, I want it to set it to 68 degrees and just leave it there, and it goes up and down. That way, it's the same idea. It's a thermistor, converts the car temperature, in-car air temperature to a voltage, and the control module uses that as an input. Usually, it's roughly in the center of the dash because you want to get a good reading from where your cabin occupants are. So usually, it's in the center. And like I said, it's just a little element like that, and samples an air. Usually, it actually kind of pulls a little vacuum, takes a little sample of the air to see how cold it is. Then also in some vehicles, they have air duct temp sensors as well. Some can have many, some can have just like one or two. It's a thermistor, converts air duct temperature to a voltage. The control module uses that as an input as well. Usually it's in the air duct itself. Sometimes, as you saw in that diagram before I got into the section, it can be pretty buried in the back as well. So good luck finding them sometimes, depending on the OEM. And then on GMs, anyways, this is what I got this one off of GM. But there are sensors sensing windshield temperature, humidity. This one, in this case, combines temperature and humidity sensors, measures the windshield temp, the cabin humidity, the humidity sensor temperature as well. The control module uses that as an input to decide how we need to run the AC system. And it's mounted to the upper windshield. In the case, I think I pulled this one off an Acadia. So that's about where that would be. And then we have our actuators. We have our door actuators, which is a reversible electric motor. It is a plastic gear reduction in there and contains a position sensor often. Sometimes they do, sometimes they don't. Operates linkages for the recirc door, the blend door doors, mode door doors, depending on what you got going on inside the vehicle. And usually they are mounted to the heater box, right? So there's two right there. There's a mode door actuator and the air mix door actuator. So the air mix door is going to go mix the air going both over the evaporator and over the heater core and mix it. And that's how we get our warmer or cooler temperatures. That's how we can do dual zone climate control, that type of thing. And then, of course, the mode door is going to be, is it on my face, is it on my feet, or is it on my defrost, or any combination of those. Actuators can have problems, of course. We may or may not have seen this in our careers, but in this case, this is a dual zone climate control. So we want warm on the left, we want warm on the right. We're not getting warm on the right. So in this case, blend door actuator was at fault. It used to be kind of wild. I remember I had a bunch over time that came through. We had it used to be manual controls with a cable and a little like metal clip at the end. And if that little metal clip broke off, or the plastic piece that was attached to broke off, you get a complaint of, oh, every time I turn left, my heater goes hot, and every time I turn right, it gets cold. So that's the blend door flopping around in there back and forth. So I saw it multiple times in the shop. So it's kind of a weird little thing. And I suppose they could break this way too, but it's probably more difficult because it's an electronic motor, and the motor's not going to allow it to move. Also, on some vehicles, they may have an actuator recalibration that you might need to do with a scan tool after you replace the actuator, because everyone's going to be a little bit different and it needs to know what the end stops of the travel are. So in this case, this is on an Acadia. Using a scan tool, perform an HVAC actuator learn an HVAC control module. Follow the scan tool directions to complete the procedure. Operate the system and verify no codes are set. If the B101E4B is set after attempting actuator calibration, verify the actuator does not have a scan tool learn status. Verify the unlearned actuator is physically rotating. Common cause of this is an actuator that's electrically okay, but fails to physically rotate. In other words, it is broken, like this one. That one's broken. All right, so we had this was on here, all right? So this gear would have been on here, and to move it back and forth, and then this would have been riding on this, and in that case, it ended up being stripped. So when it's stripped, it's not going to move. So if it strips like at the end of travel, then it's going to get stuck there forever. If it skips in the kind of in the middle of travel, you might have some unexpected operation. It might be able to make it past, it might not, but Common to damage because they're plastic gears. Trying to move stuff, and if one of those blend doors gets stuck for one reason or another, then that could be an issue as well. All right, let's go in the shop and we'll talk about a couple different things we'll do in the car and under the hood, talk about some data, talk about some functional tests, talk about some guided component tests. So I will leave you and be back shortly. All right, so today we have a 2020 Ford Expedition, and the customer complaint is that the AC is not blowing as cold as it used to. Now, it's already been to another shop, and they put dye in it, they evac'd it, tested it, but he said it's still not quite right. So we're just going to go through a couple different things. First off, in the car, we're going to go through and just see the data we can see, any functional tests that we might be able to do. So first off, we can go in the engine. And we can see a couple things in the engine. So say like there is some data you can go in and you'll get AC data, for example. And you can see different clutch engagement. It's mainly going to be on the compressor stuff in the engine data anyways. Disable reasons, request messages, cooling fan as well, fan output. But it's going to be mainly the AC compressor and the fans, and that's pretty much what you're going to see. And then as far as functional tests, if we go into output controls, you can see, let's see, AC clutch, turn it on and off. Let's see, there's only a couple different things. Let's see, high-speed engine cooling fan, low-speed engine cooling fan in there as well. And that's pretty much all you have in the engine. Now, this one kind of has a unique situation as well, because you would think that perhaps it may be in the heating, ventilation, and air conditioning module. This one does have a rear module that we can go into. So if we go in there, we see we have codes and data. There's really no functional tests for it because that's in a different module we're going to see in a second. But as far as data, it's just going to be the basic data that you're going to get out of the control panel in the rear for the rear AC, right? Cooled seats, power buttons, power supply, that sort of thing. You see it's not even that many PIDs. So that's just for the rear HVAC. This does not have a front HVAC module. It's actually contained, if I go down here a little bit, into the, there it is. In the audio, video, and infotainment, you're going to see controls interface module for the front, and that's where you're going to find your data and your functional tests on this vehicle for the HVAC system, because it's got the control panel in the front. So data display can go in there, and we'll see AC demand, blower speed. So right now it's reading like 20 steps. So if I wanted to bring that up a little bit with the fan speed, I can do that. You see how it's changing up to 34, 41, 50. All right, so that's your almost 60. So that's your up and down as I'm moving it up and down. We can see the different temperatures. So right now the engine's not running, compressor's not going. So we're just kind of sitting here in ambient temperature. So you can see evaporator temperature 71 degrees, internal ambient temperature 69 degrees, because actually it's blowing a little harder than it was before because I turned up the fan. So now we can see the ambient temperatures going down a little bit. Different blend door, floor temperature. So it's got different, has the different temperature sensors within the ventilation system, I guess, the ducting. That's the word I'm looking for. So you got the temperature sensors and the ducting as we saw earlier. So you can see that. Different key positions, climate, seat modes, and things like that, right? Mode doors, blend door positions, and so on. And also in here is where we're going to find our actuators for our doors. So if we go into, say, output controls, so you can see in here different mode door positions, AC, automatic. So it's basically duplicating the buttons and sending the bidirectional commands for that, changing the blower up and down, changing which way the mode doors and blend doors go, things of that nature, right? All right, so now we're under the hood, and let's take a look at a couple of guided component tests we can do that relate to the AC system as well. So we have AC compressor clutch is the very first thing there. So we'll go in there. Component information. Compressor clutch voltage is supplied from the battery junction box. Ground is supplied by the PCM. When the clutch is engaged, the compressor is driven by the drive belt. Makes sense. We talked about that earlier. And that's just basically 12-volt power and control. So we back up. A couple tests that we can do. We can do a DC voltage test to check for 12 volts. And also we can check the other pin for no good ground. We can check and make sure there's no voltage present. And then we also have a resistance test that we can do. So we'll connect the red and blue across the two coils and check for resistance. And it should be less than 3 to 5 ohms. If it's out of range, suspect a faulty clutch coil. And then we also have the AC pressure sensor, right? So the pressure sensor, if we look it up, it's used to monitor the compressor discharge pressure and sends a variable voltage signal representing the pressure to the PCM. PCM will interrupt the AC compressor operation when the pressure transducer indicates that high system discharge pressure. It's also used to sense low charge conditions. If the pressure is below a preset value for a given ambient temperature, the PCM will not allow the clutch to engage. So if it's too low, it just won't turn on the compressor anyways. And then we're going to connect it at the transducer itself. So we have signal return, we have AC pressure, and we have a reference voltage there. Also, there's a tech note here. It says it's not necessary to recover the refrigerant before removing the AC pressure transducer. So that's kind of nice. All right, so we can do a DC voltage test, which we're actually hooked up to the sensor itself. So we'll go to DC voltage test. And then it says AC pressure transducer pin 3, which is the yellow-green over here, and black to a known good ground. With the ignition key on, the voltage reference from the PCM should be 4.7 to 5.1 volts. So it's a 5-volt reference on this one. So with a view meter, it's going to open it up for us, and look at that, 5 volts. All right, so 5.04, which is less than 5.1, so that's right in between. So that is perfectly fine for the spec there. So good to know. So you can see we have miscellaneous scanner functions that we can do with the scan tool in order to function things on and off. We can check the data for various things. Also remember, on this particular vehicle, it's not in the HVAC control module. It's actually in the front button controls module. And then we also have guided component tests that we can do out under the hood for check miscellaneous sensors and the AC clutch and things like that. So back to the studio. All right, good stuff. Good stuff. So that is AC, right? So we can kind of test all of our different components and turn clutches on and off, and we kind of know how things work now. So hopefully you got a little nugget out of this. So that's AC. So let's talk about what we're going to talk about next week. Next week we are on to ignition system analysis and testing, and this is one of my more favorite subjects because I get to use the scope with it, right? I love using the scope to see things, and you can tell a lot about what's going on inside the engine compartment or inside the engine itself if you know what to look for on an ignition pattern. So we're going to talk all about that next week. So same time, same channel, same place. Every Tuesday at 7 Central, we go on YouTube and Zoom. If you want to sign up for Zoom, you go down, see the bottom there. It says snapon.com/OT. You're going to click the link to sign up. And then Wednesdays, we go on Facebook, 7 p.m. Central. So that's Snap-on Diagnostics Product and Training is the Facebook page. That's the right-hand QR code if you scan that. Left-hand QR code is going to be for our YouTube channel. So check those out. If you want to see any of the other episodes in this series, with this episode 142, I guess it was. We're up to 147 episodes. Looks like we got 5 more left before we start brand new ones again. But anywhere from intro to ADAS through pressure transducer diagnostics and everything in between, you can go watch them half an hour or so, every half hour, or about half an hour long or so, and go check them out. It's free training, free diagnostics training. I don't know anybody else who does free diagnostics training like this. So definitely check them out. There is a playlist for live training on the YouTube. Also, are you receiving emails from us? Things like tech focus articles, SureTrack blogs, quick tips, new product releases. They send out my schedule periodically as well. If you're not getting that type of content and you're interested in getting it, you can scan that QR code there. It'll bring you to a little page. You put in your particulars, and then you will start receiving those valuable email information. So check that, and that's all free. Crazy. All right, time for questions. If you do have a question on the Zoom, look up at the top of the bottom of your screen, wherever your Zoom controls are. So you'd see a Q&A button. Type in your question. I'll get to them in a second. If you're watching on the YouTubes, feel free to use the live chat function. So it looks like I got a couple on the Zoom here. Let's see. So Daniel asks, when using an automotive AC recover and recharge machine on vehicles that require different types of refrigerant oil, how does the machine prevent incompatible oils from mixing or being introduced into another vehicle's AC system? And that is why we need to worry about having separate machines, really, in that case. Um, just because we don't want to cross-contaminate the oil, we don't want to cross-contaminate the refrigerants. And then they shouldn't be incompatible with each other as long as it's the same. Because we had the ND oil. The hybrids is a totally different case. And now 134 has one oil and 1234 has a different oil. So the machine themselves on that, like that dual machine, it has two totally separate systems in one. Standard machines, you're injecting oil often. There are machines that automatically inject the oil as well. So you just need to be cognizant, I guess, in those cases of what you need to do and what oil you need to use. So good question there. The electric vehicles work the same as regular mechanical vehicles. As far as like the way the system works, yes. So they'll have an evaporator, they'll have a condenser, they'll have it's an electric pump instead of a mechanical pump. Especially since EVs don't really have the internal combustion engine to turn the pump, so they just power it by the battery, right? Um, and then as far as the Polartec machines, there's one that does both 134 and 1234. Yes, but it's not the new style yet. It is the that one I showed earlier. Let me see if I can find it real quick. Let me see. So it was, where are they? This guy right here. And in this chart, it's this guy right here. I believe they made an upgrade to it, like some of the internals, if I'm not mistaken, but that does both sides of things. Good question there. And Jay says, thanks for the class. You're very welcome, Jay. Thanks for attending. Always appreciate it. Then on the YouTube, we got this. Tanya asks, is it okay to add dye to the oil in the Polartec machines? Yes, that is okay. Um, very similar, but upgraded from the predecessors. So yes, you can definitely put dye in the oil. Oh, no, never mind. I'm thinking of something else. I was thinking of the EVAP machine. It does air only. Actually, this one does. Actually, no, wait. The new machines do have a nitrogen setting, I believe it is. Nitrogen or hydrogen. One of those inert gases. This is not really my product line that I study with. But it has some sort of gas injection where you can use a hydrogen detector. It must be a hydrogen detector because hydrogen is super small, right? So you put the inert gas in there first. You suck it down, you put an inert gas in it, and then you use a gas detector to detect it so you don't have to use dye. You can use dye, but you don't have to in that case. Yep, I definitely don't know everything about them either. I've had very minimal exposure to those at the moment. Um, I did some classes for franchisees, and I was one of the stops, and one of the other stops was the AC machine. So I kind of got a little bit of background off of that, but it was not nearly enough time to spend with it to know all the specs and facts. All right, thanks, Tanya. Let's see, and then this is okay, let's see. Mahendra on YouTube says, I understand the strings about AC systems. I also need help with the ADAS calibration. Currently at dealer tech, I have no problem with the dealership scanner. It's only with Snap-on scanners. Probably doing aftermarket cars, I would guess. It kind of got cut off at the end, the question there. But the Snap-on scan tools should work on pretty much anything you need to do. I did do a whole series last year, like every other week last year. I did one on different OEMs and actually walked through some of the procedures using the Snap-on scan tool. So I think those would probably be of good help to you. Otherwise, you could also, send me a message on Facebook, I guess, with some particular questions if you have some more in-depth questions, and I can answer them to the best I can, or at least send you in the right direction with some other material that can help you. So hope you're still watching, because I know that was early on in the class. Jay Lee Lobo says, hello. Concerned Citizen said, when are you doing CAN bus? So if you go to the YouTube channel and go to the playlist, there's probably 4 or 5 different classes I've done on CAN bus. I haven't done one in the last probably 2 years, but yes. I have a fair amount of material. I haven't done any recently in the last 2 years, but it should all still be current relevant information on those up there. Auto Repair Tech says, can you talk about the differences between the refrigerant leak testers and Snap-on offers? Not intelligently, I'll tell you that right now. Once again, that's equip. You kind of have to understand how the company's structured, right? So Diagnostics is its own little baby over here. We got equipment over here. We got hand tools here. We got power tools here. And usually we don't intermingle too much. Don't do a lot of cross training, so to say. So I can't. I mean, I guess there's die ones and there's sniffer ones, right? And I don't know if we 100% make a sniffer one. I think we recommend a different one that's available through our supplemental catalog. So, unfortunately, sir, I cannot. I can't answer your other question. Now, let's see. Don says, thanks for your classes. As you said, you're really the only company providing this type of content. Thank you. I do see other companies kind of starting to do a little bit, but it's going to take a while to get to where we're at. But, you know, I enjoy providing free training, because the other nice thing is you can answer that question. If you're on a Snap-on truck, almost inevitably somebody comes up through the day, because we'll do ride-alongs on the truck, right? So inevitably somebody's going to come on during the day. Hey, Snappy, what's free today? Training. We got free training. 147 episodes as of right now, right? So with that. Auto Repair Tech also, is there any way to screen record on the Zeus Plus? Yes. There is a free software that you can download called OBS Studio, and runs native on Windows. And then you can set it up to record. Also, you can set it up to do tons of things as well. I use a little bit of it to like do the countdown to the beginning and stuff. But I just set it on there and set it to record the screen. Hit start record. Once it's done, hit stop record. It saves it to your My Videos file, and it's just everything you did on the tool. That's how I do any on tool stuff you see on a Zeus in any of those in the shop videos that I do. It's all OBS. It's free and it's super easy to use. Okay, and then Don says, we have several sniffers. You know what? Let me learn something today. Or let me see if I can maybe help us both learn something today. I'm not sure if I will be able to. I will look in the Snap-on catalog. Should be shop equipment, right? AC. And I do understand that our Snap-on's website isn't that easy to navigate, at least for the store. Ultraviolet, manifold testers, valve core, ultraviolet leak detection with LED lights, metered UV injection, cam temper valves, vacuum pumps, thermometers, manifold gas, refrigerant scales, ultraviolet leak detection. I don't see any sniffers on the page. It might be in supplemental. It might be why it's not here. Yes, I am. I will apologize. How about this? Dawn, if you could send me a message on Facebook. It's Jason Gabrenas Snap-on. It's very, very, I think I'm the only one. Or you can go to our Facebook page, like our regular, like, diagnostics and training page. And then send me a message and I'll do a little more research on it. I'll get with somebody over on equipment and see if they can help me out a little bit and maybe send me some material. I will definitely do that, but you need to send me a message so I remember. That's all. All right, looks like I got another one. A lot of chatter tonight. Let's see. What does one test to do to identify when you have a bad valve or a bad internal compressor, even though the clutch is moving? So anytime I've seen it, at least the bad expansion valve, is going to be, you look at your gauge and it's going like this. It's going nuts. You use an analog gauge and it goes crazy like that. That's usually how I could tell I had a bad expansion valve. As far as on the compressor, if it does have like the speed sensor like we talked about earlier, you would be getting no data from the compressor, but the clutch would still be moving, I would suppose. And that's pretty much all I can have off the top of my head right there. Yeah. Let's see. Daniel says the Snap-on make refrigerant identifier for R134A systems that can test the refrigerant for contamination before connecting to an AC recovery machine. I do know that we have it built into our recovery machines. I do know that much. So we do have a refrigerant identifier built into the machine. As far as a separate standalone one, I'm not sure. That's the best answer I can give you. Like I said, AC, as far as equipment wise, not my thing. I live, breathe, and eat scan tools. So. Tanya says, see you next week. Brush up on those sniffers. Yeah, absolutely will. And then Pedro says thanks. So good there. And then boy, oh boy. Renegade's Garage says, hey everyone, thanks for the help, Jason. Making great training, says Auto Repair Techs. And Rob Jocelyn and I just bought a discontinued Snap-on sniffer and it worked great. Great. Perfect. Love it. Love to see it. And okay, I got those two. All right, cool. A lot of questions this week. Not bad. All right, so with that, nice. ACT 795UV used for 50 bucks. Good job. Good job, Rob. All right, with that, thank you very much. Thank you for spending a little bit of time with me. Thank you for the good conversation we have this week. Hopefully you'll join me next week for Ignition Systems. With that, enjoy the rest of your week. Enjoy your weekend. Have a nice night, and take care. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.